So all of the code that we've written so far in this tutorial series has really just been a straightforward sequence of instructions. Maybe it's printed some stuff out to the screen, got some user data, done some calculations, printed some more stuff out or whatever. But the program pretty much runs the same each and every time, and it really doesn't make any decisions for itself. And while the process for having your program decide things for itself is primarily driven by the vehicle of the if statement. And how an if statement works is, well, you type out the word if and then you throw a set of parentheses down afterwards. Now, within these parentheses goes a test condition. And we're going to use this test condition to see if it is true or if it is false. And then after you've typed that out, we're going to drop down and we're going to put a set of open and closed curly braces here to form a code block. Now, what happens here is if this test condition is considered to be true, then we're going to execute the code inside of this code block. And if that test condition is found to be false, then we're going to skip the code inside of this code block. So in essence, you can have the program sort of make decisions based off of a series of test conditions. And so, well, one thing else I want to point out before we get any further is that this is one of the rare exceptions in C++ where a line of code doesn't end with a semicolon. This header for this if statement here just drops down, no semicolon necessary. As a matter of fact, if you put one in there, you may get unexpected results. And so let's see this in action a little bit. Let's get some intuition for how an if statement truly works here. And so let's say that we are going to write a program that, I don't know, keeps track of the amount of eggs that you have in your refrigerator. Okay, so we might want a variable eggs, this integer here, and then say we prompt the user to enter in the number of eggs that you have. So enter the number of eggs, and then after they have done that, we'll see in that value into that variable eggs, and now we'll start making some decisions based on the number of eggs that the user has entered. We'll say that we have this tray in our refrigerator that holds exactly a dozen eggs, and any more than that, this tray is going to overflow and we don't really have a place to keep eggs otherwise. So we'll say, for instance, that if we're going to use a relational operator here, because remember, relational operators return a true or a false depending on, well, whether the statement is true or if it's false. And so we can take this variable eggs and we can say if eggs is greater than 12, then we're going to see out to the screen, eat some eggs, right? Because we have too many. Now, let's run this, for instance. So let's just go ahead and run this. So enter the number of eggs. And so if we have like 15 eggs in there, well, 15 is indeed greater than 12. And so this line, eat some eggs, gets printed out to the screen. Now, let's say that we have exactly 12 eggs. Well, you see that nothing happens here, because even though the egg tray is full, 12 is not greater than 12, and that's what the user has entered in for the number of eggs. And so anything 12 or less, eat some eggs, isn't going to print out to the screen. Just nothing is going to happen there because that statement is false. Well, we could actually, if we wanted to make our program a little bit more robust and complex, stack some of these if statements. For instance, we can say if eggs equals 12. And so now we have a whole nother if statement down here. And then we can do something else with it. We can say see out, I don't know, for instance, eggs. No, we'll just say it's full. We'll just say the tray is full, and then we'll drop it down a line here. And so what's going to happen here is that the user is going to enter in some number of eggs, say 13 eggs. And if the eggs is greater than 12, okay, eat some eggs is going to print out to the screen. But this next if statement is still going to be considered. So you can have more than one if statement being considered in the same program. And if you stack them like this, well, if eggs is equal to 12, well, it's 13, so it's not equal to 12. But we'll just say that it's full at that point. So now we have two different branches our program can go into. Three, technically. Either nothing could happen because, well, we have less than 12 eggs, or eat some eggs can print out, or full can print out. So now we have our program sort of making one of three decisions for us based on the number of eggs that we have in here. So 13, eat some eggs, prints out. But then we got 12, and then we'll just say full prints out. And for, I don't know, a little bit more completeness sake, let's say that, one more example, we'll just say that if eggs is less than or equal to 3. Say that we want at least 3 eggs in the refrigerator, just in case. Then if it's less than or equal to 3, then we're just going to say that our eggs are running low. And, well, let's test that condition out. We can enter in 1 egg and then just low prints out because, well, these first two conditions get skipped because 1 greater than 12 is a false statement. 1 equals 12 is a false statement, but 1 is less than or equal to 3. So this line gets executed, and only that line gets executed. Which sort of brings me to the next topic. If these things are considered false and this one's considered true, what exactly is truth as far as this is concerned, right? So let's we've covered a little bit about what truth is. We were talking about these relational operators where we were, say, outing to the screen statements like 2 is less than 4, for instance. And, we printed this out to the screen and we saw that, well, C++ considers a true statement to be equivalent to, say, a 1, an integer 1. And if we put a false statement in here, let's say 7 is less than 4, that when we run this, C++ considers a false statement, well, to be a 0 in those terms. So the interesting thing is that, well, you can actually shortcut the system in a way and just plug in a 1 or plug in a 0, and that's still valid. I don't know why you would do this, because this statement would always be true, right? But you can say if 1, then we'll see out to the screen that we'll just see out to the screen 1, okay? And then we can say if 0, which this statement will never execute because it's always false. It never changes. But we'll see out the screen 0. And, well, that'll never be printed out to the screen because, well, this is always going to be false. But when we run this, we see that there's our 1 because, well, 1 directly is considered to be true. Well, here's the thing, is that C++, even though it'll only return, say from like our relational operators, a 0 or a 1 for truth or falsehood, it considers any non-zero value to be true. So for instance, we can say if 9, right? And, well, that's a non-zero value. So if that is true, then we should see a 9 printed out to the screen. And when we run this, well, there's our 9. So it's a non-zero value. So as it turns out, not only 1 is considered true, but any non-zero value can be true. And, well, this includes negative values as well. We can say if, for instance, -3, as a arbitrary example here, and then we can see out to the screen that -3 is considered to be true if it is considered to be true by this statement here. And, well, we can run this, and, well, there's our -3. So we see that that is also considered to be true. Now, this is useful for, say, instance, if you had your integer eggs up here, and say that eggs equals, 5, well, then we can say if eggs. We don't have to say if eggs is greater than anything or nothing. We can just say if eggs. Then we're going to see out to the screen that you have eggs. Because eggs equals 5 up here, and we know that any non-zero value is going to be considered true. You have eggs is going to be printed out to the screen here, right? And so to test this out, when we run this, you have eggs prints out to the screen because, well, we have 5 eggs in our refrigerator. But if we were out of eggs, if we, got down to 0 eggs and we run this, then you have eggs does not print out to the screen because, well, we don't have eggs because our eggs integer is 0. So even though this is an integer, when it equals a non-zero value, it is considered true, and when it equals 0, it is considered false, just like C++ returns to us when we execute relational operators or whatever. Now, also, I have to say that we learned about the bool data type earlier, and this obviously returns a true or a false, so we can, see if the TV is on, for instance. And so we can have this bool variable is on or something, and that can be true. And then if that is true, so if is on, then, well, we can drop on down here and we can see out that this thing is on. Otherwise, nothing will happen if this statement is false, right? So it's on because our is on Boolean variable, it has a true value there. And well, if this were to be false, as you might expect, is on will not print out anything. So this is a quick intro to if statements and a little bit about what truth values if statements accept. There's going to be another at least couple of videos on decision making in C++. This sort of just scratches the surface, but quick intro. All right, see you in the next one.